as we start to configure and work with the Palo Alto firewall, it's pretty important, I think, to make sure we have an idea of how we're going to deploy it, what our options are. And what I'd like to do is walk you through some of those concepts as we make our initial plans on how we're going to deploy and use the Palo Alto firewall. Let's begin. In our previous nuggets in this course, we've configured the management IP address on the Palo Alto firewall, the one in our virtualized environment. And I thought it would be important for you and I to chat for a moment about the differences between the management plane that we're going to use to manage and work with this firewall as an administrator, which is also, by the way, the same management plane that the firewall is going to interact with services, for example, NTP and DNS requests and so forth on the internet, and compare that and contrast that to the data plane. Whenever we hear the word data plane, I'd like you to think end users. And let's go ahead and use Bob as an example of a very happy, look at that smile, a very happy end user who's on the inside or the internal part of our network. And if Bob wants to communicate, for example, out to a resource on the internet, that traffic is going through the Palo Alto out to the server on the internet, and then the reply traffic is coming back. That traffic that we just did here in blue is an example of the data plane. That's the user traffic that's being moved through the appliance. Now, the data plane would also apply to users that are out on the internet. So, for example, maybe Lois is out here on the internet, and Lois wants to get access to one of our public servers. So Lois's request comes in, goes up to the server, our server responds back to Lois, and that would also be an example of a user's traffic going through the appliance, and that would also be an example of the data plane. So whenever a user's traffic, whether it's from the inside or the outside, is going through the firewall, that would be considered to be using the data plane. And when moving that traffic through the firewall, we have interfaces involved. For example, here over on the right, we have the 1/1 interface on the firewall that's connected to the outside world. We've got an interface over here, 1/3, that's connected up to this server 1, one of our DMZ servers. And we've got interface 1/2 right here, which is connected to an internal portion of our private network. So as a quick recap, the management plane is going to be involving our management interface and our management IP address. And the data plane is going to be involving the other more traditional interfaces on the Palo Alto firewall that are being used for the actual firewall functionality that the users, whether they be external or internal, are using through that firewall. I also want to point out, just for this lab that we've built, we are doubling up as far as what networks we're using. So for the management plane, we happen to be using the 192.168.1 network. And also for the data plane, we're also using that same subnet. And that way I can have a PC, for example, that's connected to the 192.168.1 network, and I can use it for lots of different things. For example, I can use it to do management without having to worry about routing. And I could also use it to test the data plane by, for example, this PC accessing a server going through the data plane as end user traffic getting to server 1. So again, in an ideal environment, in a production environment, we'd have these separated out, with the management network being completely isolated from any end user traffic. And that could be accomplished by having a different VLAN for each one of them, a different subnet for each one of them. One for the data plane on the outside and one for our management network. So moving forward, we're going to just understand that we've got a management interface, that it's got a management IP address. And for most of all the rest of our discussions, we're going to be focusing on the interfaces that are going to be involved with the data plane, end user traffic that's being forwarded or moved through the firewall on behalf of those users. And as we begin to look at those interfaces, in our case it's 1/1, 1/2, and 1/3, we have several options regarding how those interfaces can be deployed. And one of the most popular options is called Layer 3. And in a Layer 3 deployment, these interfaces are simply treated like a Layer 3 interface, very much like an interface that we'd find on a PC, for example, or on a router, where each interface can be assigned its own IP address. And because it does have multiple Layer 3 interfaces, there can also be routing done between those interfaces. Also, because they're Layer 3 interfaces, we have features that we can use, such as network address translation. And in our design, that's how we're going to deploy, at least for now, these interfaces. So here, connected to this router, I've got interface 1/1 on the Palo Alto. Now also in a production environment, we're also likely to have some switches, some Layer 2 switches that are interconnecting between, for example, this router and the Palo Alto firewall. Just for simplicity, I'm just showing the logical network segment between the Palo Alto and this router. And the interface that connects the Palo Alto is 1/1, and we're going to use that in layer 3 mode, which simply means it's going to act like a layer 3 interface and it's going to have its own IP address. On the left-hand side of this Palo Alto, we have a 1/2 interface that's connecting to an inside network, and that inside network is 10.1.1.0 with a 24-bit mask. It also is going to be configured as a layer 3 interface type, and we also have 1/3, interface 1/3, which is connected up to a server 1. We could have server 1 be part of a zone called DMZ. We'll talk more about zones here in just a moment. And this interface 1/3 on the Palo Alto would also be configured as a layer 3 interface. Now the question might come up, okay Keith, all of our data plane interfaces 1/1, 1/2, 1/3, they're all being configured as layer 3. Well, what are the other options? I'm glad you asked. The other options that we could use in a slightly different design would be something called a virtual wire or a vWire. And using a vWire approach, we can sneak in the appliance into our network without having to do any type of readdressing. For example, if we had some routers, let's say we have router 1 and router 2, and they're connected to each other logically, and very likely there's a switch in there somewhere, what we could do is we could actually separate those so they're no longer connected, and we could put our Palo Alto firewall right here. So let's say that on the Palo Alto we're using interface 1/1 and 1/2, and they're configured together. And let me go ahead and separate these. And we're using these interfaces as part of a vWire configuration. The traffic from R1 has to go through the firewall, and as it goes through, the Palo Alto is not going to perform any type of routing or switching services. It's just going to be able to analyze and enforce policy without doing any type of switching or routing on that traffic. So the traffic going from R1 to R2 would go this way through the Palo Alto and over. If R1 and R2 are connected on the 10.12.0.0 network, and that's how they're connected initially, and then we add the Palo Alto, we don't have to readdress. R1 and R2 will still believe this common segment between them is one common subnet of 10.12. It's just now that we have the enforcement of policy that we can do with the PA stuck in between them. There's another option besides vWire that also has very similar characteristics, and that is to use a layer 2 solution or a layer 2 implementation for deploying our firewall. And if you squint, the layer 2 solution looks a lot like the vWire in that we don't have to readdress, except the layer 2 solution also includes the ability to use something called VLAN objects and has some switching capabilities that we will talk about in a later nugget. And in both of those cases, vWire and layer 2, we do not have to do any type of readdressing between adjacencies because that type of implementation kind of looks like a bump in the wire as opposed to a routed hop. There's also options with our interfaces to configure them for high availability. A high availability interface is used for the replication and synchronization of configuration information between two firewalls that are acting as a high availability pair. And it can also be used to go ahead and synchronize the state information between the two. And we'll have separate nuggets on high availability. The last one I want to talk about here, at least in this nugget, is TAP. If we wanted to collect information and analyze it, for example, let's say we're doing port mirroring, and we're taking all the data from somewhere in our network and we're forwarding it over to the Palo Alto, we could use a TAP interface to collect that information so that the firewall could analyze and look at that data. So to summarize our interface options, we have layer 3, which is what we're going to be using primarily here, vWire in layer 2, high availability, and TAP. One of the lessons I learned really early on in security products is that routing is important. For example, if you and I are given a hot potato and we have no idea of what to do with it, it's very likely we're going to drop it or send a message back to the recipient saying, hey, I don't know what to do with this. And that also applies to a firewall that's configured in layer 3 mode. In order for the firewall to take advantage of some of the advanced features, for example, looking at the payload and making decisions based on should this go or should this not go, or based on security policies, it has to have a route and know where to forward that packet. And that can be done from a routing table. We can also use policy-based forwarding. And you might ask, well, Keith, didn't we already set up a default route? And the answer to that is, in an earlier nugget, we set up a default route, but that was just for the management plane. If we want a default route for the data plane, we also need to set that up as a separate routing entry. And if we did configure a static default route, that would be in the data plane routing table. Now, I want to share with you some interesting news about the routing table on a device. Let's go ahead and take a router as an example. So here's an icon, a fairly generic icon for a router. and I'll also label it so we know exactly what it is. So on a routing device, as we connect network interfaces to it, let's say we have 4 interfaces, and let's say that this is the 10.1 network and 10.2 and 10.3 and 10.4. From a basic routing perspective, the moment that those interfaces are configured with those IP addresses and those interfaces are up, the routing table on this router is going to have 4 directly connected routes. It knows how to get to 10.1, 10.2, 10.3, and 10.4 because it's directly connected to each of those networks. And those routes would all show up in what I like to call, in general, the global routing table of this router. However, there is a feature in many networking devices where we can basically partition the routing table. We can, for example, maybe put these 2 interfaces in routing table A and these 2 interfaces in routing table B, and then we'd have 2 separate routing tables. In routing table A, we'd have routes for 10.1 and 10.2. In routing table B, we'd have routes for 10.4 and 10.3. And you might be asking, okay, Keith, I get the concept. In Cisco, this is called using a VRF. I'll put that in a different color so we can see it. So a virtual routing and forwarding instance. And that's where we can partition and have multiple little mini-me routing tables that all coexist in a single physical router. Now you might ask the question, okay, Keith, I get that concept. How does that idea of having separate routing tables apply to this beautiful box that we call the Palo Alto Firewall? And the answer is we have the same type of feature from a data plane routing perspective on the Palo Alto Firewall. And they're called virtual routers. Now regarding virtual routers, there's a default virtual router. And as we configure layer 3 interfaces, we are going to be asked what virtual router do you want to add these interfaces to? And if we say, hey, we want to add this to the default virtual router, then that default virtual router routing table would include those 3 IP addresses, and from an IP perspective, more importantly, those 3 associated IP networks that those interfaces are connected to. Now, if we had a box with lots and lots of interfaces, and we wanted to have a separate virtual routing instance that included a few of those other interfaces, we could create, for example, a virtual router on the same physical box called VR1 as an example. And I just realized I called this a physical box because I'm looking at the topology. In our environment, it's a virtualized firewall, but whether it's virtual or physical, the concept is the same. If we created an additional virtual routing instance, if you will, our virtual router called VR1, and we had 3 more interfaces, let's say we have interface 1/4 and 1/5, when we configure those as layer 3 interfaces, if we associate those with VR1, then the routing table for VR1 would have those 2 specific networks that those 2 interfaces are connected to. And one of the benefits of this, if we had multiple different departments or groups or even companies that we were serving, and we wanted to go ahead and have different routing tables and different interfaces dedicated for each of those departments or groups or companies, separating out those interfaces into different virtual routers would be one step we could take for the isolation between the 2 sets of traffic. Another big challenge that comes up when implementing a firewall appliance such as the Palo Alto Firewall is making sure that we not only have a good idea of what the rules should be, for example, what the security policy should be, but also making sure that it's implemented correctly even if we have dozens of interfaces on a Palo Alto Firewall. Because besides the physical interfaces, we can also create sub-interfaces to support VLANs and support features such as 802.1q trunking. So how do we manage our security policy? And somebody really smart a long time ago said, you know what? Let's just consolidate interfaces and put them into different groups. For example, we may have a group of interfaces that all connect to our internal users. In fact, let's just use this one right here. So let's imagine that interface 1/2 connects from this Palo Alto Firewall to a switch, and that further connects to routers, and that connects to sets of networks. But they're all networks that are inside of our company, internal to our company. So what we could do is we could go ahead and take that interface and assign it to a zone. And maybe we call that zone inside. And this is just a name. We don't have to use the quote-unquote name inside, but this inside zone could represent multiple interfaces that are all part or connected to our internal network. So maybe we have in a production environment, for example, 1/2, as we do right down here, and maybe we also have in a larger environment 1/5 and 1/6 and 1/7. And if all of those physical interfaces, which also we can set up sub-interfaces, are connected to our internal networks, we could just dump all those interfaces and associate them with a zone called inside. And the benefit is we can then set up policies and rules based on the zone, and then any interfaces that are part of that zone will comply and enforce that policy. For any interfaces that are connected to, for example, the outside world, the internet or other networks that we don't trust, perhaps we create a zone, and let's imagine that we create a zone called outside. Again, this is just a name that you and I create with the Palo Alto, and then we can assign rules based on that zone. So here we have interface 1/1, and if we had another service provider perhaps that we are going out to, maybe we have interface 1/9. And again, the cool thing is any rules or policies that we set up regarding the outside zone and interaction with that zone, because the firewall knows that these interfaces are part of that zone, it can enforce that policy. And in the future, if we have new interfaces or sub-interfaces that we're creating, we can simply associate them with a specific zone and our policies will continue to be enforced. And then based on our topology, we've got another connection over here, 1/3, that goes up to our server. So let's imagine that our server 1, and maybe there's a bunch of servers in this DMZ, this demilitarized zone. Maybe we create a zone called DMZ. Then when we configure interface 1/3, we associate it with that zone. So if we have a few interfaces there, let's say we have 1/10 as well. And the cool part is that you and I can set up our policies based on zones. We could have rules, for example, to say any traffic that's trying to go from the inside zone, which would be an example of this user here, Bob at PC1, that's trying to go out to the internet. Let's follow that traffic. So Bob's traffic would go in on interface 1/2. It would be routed. Assuming we have interfaces set up and routing set up, it'd be routed out this 1/1 interface as it goes out to the internet. So if this initial flow started on 1/2 and it was going through the outside on 1/1 right here, any policies that we have set up between these two zones, between the inside and the outside, those would be applied. Policies such as what's allowed, policies such as what's inspected, policies such as should we do network address translation on this traffic, and if so, how should we do it? And a similar concept for a user on the outside who is trying to access a DMZ resource. So for example, Lois makes a beautiful HTTP request. It gets resolved to an IP address that leads to the server. That traffic is brought to the firewall, coming in on the 1/1 interface. So for Lois's traffic, I'll circle that in red. That's where it started. And it's going to be routed based on the routing table on the Palo Alto. Out interface 1/3, and that's going out on the DMZ. So the initial flow here is from 1/1 to 1/3, which would be outside to DMZ. So any rules that you and I implement, any policies regarding network address translation, what's allowed, what's inspected, and so forth, all those rules can be implemented based on the policy we have on the initial flow of traffic between two specific zones. And that's going to be a pretty common model on most firewall implementations that we implement, whether it be from Palo Alto or from other vendors as well. And it's time for the assessment check. Take a moment, pause the music, answer these questions, and we'll be right back to review them together. And here we go. Question number 1. What is the name of the default virtual router? And in the nugget, we talked about it just for a moment, but the actual default virtual router is literally called default. And we'll see that again, by the way, when we go into the interface and we start configuring and creating additional virtual routers. Question number 2, which interface deployment option allows routing and network address translation? And the answer is that would be a layer 3 deployment, where each of the interfaces have an IP address, and from a layer 3 perspective, the firewall can act as a router. I think of it like a router with an attitude, and that attitude is going to be adjusted a whole bunch based on the policies that we implement on that firewall. Which leads us to question number 3, how is zone-based policy better than interface-based policy? And the answer is sanity. What do you mean, Keith, sanity? Well, if we have 15 interfaces, which may include physical interfaces and sub-interfaces, it would be quite a pain to go into each of those interfaces and associate specific policy regarding this is allowed or this isn't allowed with each and every interface. Instead of doing that, we could create our zones. For example, the inside, the outside, the DMZ, the VPN zone, a zone perhaps for guest users. And then we could simply set up the interzone rules between zones. And then once we have our policies and those rules in place, we simply add those interfaces to the appropriate zones and our policy is enforced. And that concept and that idea of using zone-based policies and rules will be strongly reinforced as we get into the details of creating and implementing and verifying policy, specifically zone-based policy, on the firewall. In this nugget, we've taken a look at some concepts that we'll be using regarding the deployment of the firewall, including the deployment option for interfaces, which we're going to start off with a layer 3 interface deployment. We also discussed the idea of zones and zone-based policies, where interfaces can be members or associated with a zone, and then based on our policies for inter-zone traffic, the firewall can then implement our policy without us having to reinvent that policy every time we add a new interface to the firewall. Hey, thanks for joining me in this nugget. I hope this has been informative for you, and I'd like to thank you for viewing.